Hello, everyone. My name is Stijn Wynants, and this is the session reporting on 1.4 billion rows with serverless SQL Pools, which is a part of Azure Synapse Analytics. I would like to start off with a story, and that's the story about the Mesopotamian Shekel. The Mesopotamian Shekel basically was the first type of currency there was in this world, which means that before the Mesopotamian Shekel, we were based out of different villages trading with each other, or inside villages trading with each other. To give you an example, if you would like to buy 2 hammers, you had to bring 20 horses to actually get those hammers. So you can understand that bringing over 20 horses was a lot of work. So basically, we tried to innovate on that, and we as a society then decided, yeah, let's make something that represents those 20 horses, and that was the Mesopotamian Shekel. And this basically completely revolutionized the way of trading, and it made everything a lot faster, a lot more scalable, a lot more performant that we wanted to have the Mesopotamian Shekel. And that basically links back for me to serverless SQL Pools, because serverless SQL Pools is also this type of innovation that reduces the amount of time, which basically gives us a performant way of querying data. And it's really, really, really like a keystone for me when looking at the way we're querying or building out our data warehouses. So the Mesopotamian Shekel, you can always, if you think about serverless SQL Pools, think about Mesopotamian Shekel, because it's like one of those key moments in our history, but for us in the data history. Now, quick word on myself. My name is Stijn Wynants. I am a customer engineer at Microsoft. Basically, I fiddle around with data all day long, and mainly on Synapse solutions. As you can see, I have started the indoctrination of my daughter. She's already starting to say Microsoft right now, so that's also really good. I enjoy cycling, so I cycle quite a lot. Like last week, 280 kilometers. I finally had some time to do it. And I also blog a little bit on SQLstan.com. It's mainly currently on Synapse, and previously it was on stuff like DBA, because I used to be a DBA. But enough about me. Let's go and see what we're going to talk to you about today. Now, I've got three things I want to teach you today. So the first thing I want to teach you is understand, not very deeply, but just understand the Polaris engine. So the Polaris engine is a white paper we released with Microsoft a few months ago, which basically describes a little bit how this serverless thing is working in the background. Then I want to show you how to read and optimize reading data. So not only read, but also optimize reading that data from a data lake using the Parquet format. I will briefly touch also on CSV and JSON, but the main focus will be on Parquet because we've got more options there and we've got more stuff to do with that Parquet. And the third thing I will show you is basically build a report on that 1.4 billion row data set, so like a really beefy data set in a performant way. So just to show you, like we start off with something normal without any alterations, and then we start making alterations to our setup to make that faster and faster and faster. So that's basically the goal of today. Now, I usually have a slide here because we have 45 minutes. I'm going to skip this, but I'm just going to briefly say Azure Synapse Analytics, kind of an ecosystem for your analytical solutions. You can ingest, explore, analyze, and visualize data. There will be loads of other sessions on the whole structure and the whole architecture here at the event today. I'm not going to focus on this. My focus of today will be on serverless SQL Pools. Serverless SQL Pools, which is basically an on-demand query engine which can query files directly out of your data lake and basically join files together and give you an on-demand query. What's the big difference with other technologies like dedicated SQL pool? You will have something running, that pool will be running at the same time, while SQL on demand basically is on demand. You say execute this query now against this CSV file, and we will give you back the results of what's inside that CSV file. If you want to do a calculation on a CSV file, it's now that you execute that. So basically on-demand serverless SQL Pools. Now a bit of background. Looking at where we came from. So if we look at our on-premises Arc, for example, when we were still working, a lot of customers still work with on-premises data. We basically have our server, and if we want to scale that server, we had to add more memory into it, or we could build a clustered setup. And basically it made the scalability a bit more difficult, and we went to PaaS solutions in the cloud where we could also separate some compute storage, scale a little bit easier. But then Polaris and serverless SQL Pool kind of went the next step. A bit more about that later. Also, the accessibility of our data is very important. So we want to make sure that we are able to access our data as soon as possible, as fast as possible, and preferably as close as we can to the source. Serverless SQL Pools basically gives us the ability to directly query those files. So if we're putting files somewhere or data is coming in a file format in our data lake, we can directly go to those files and build logic on those files to basically build sort of a logical data warehouse, we call it, or if you want to explore your data, that Serverless SQL Pool generally gives you that accessibility to your data. And one of the most important things is if you have this tool and if you have all these capabilities, you want this to work in a performant way. You don't want to wait 40 minutes to query a file, because then it kind of loses its objective. You want this to be performant. If you have a SQL on-demand query engine and you want to quickly explore data, you want those results to be there instantaneously. You don't want to wait 20 minutes for a cluster startup. No, you want that to execute now. Okay, and that's a bit where serverless is coming from. Now, looking at our Polaris paper, if we look at where we came from, the Onpremises Arc, basically what you could do to scale out was doing a clustered setup, but it's basically a shared nothing architecture. It has limited scaling and it is quite failure prone. I used to be a DBA, so I can still remember the days I was called up at 3 o'clock in the morning because I set up a nice clustered setup, which was really, really well set up, which had high availability, but still that full cluster failed because of something we missed. And basically that on-premises Arc then kind of reached its limits because you always stuck to the machines that you're working with, the hardware that you're working with, and then we actually evolved into the next step, which was basically the cloud move. And in the cloud move, we did something new, which was on the PaaS. Not if we go to VMs, IaaS in the cloud, but if we look at the Polaris and where we moved from. So we come from on-premises, then we went to the PaaS solutions that we have now, like with Azure SQL DB or dedicated SQL pools. And that's where basically where we separated storage and compute. So compute could scale independently, storage could scale independently. Those scale operations would still sometimes cancel queries or might impact or disrupt your current state of business, but not in the way like you would upgrade a clustered setup. If you want to upgrade a clustered setup, it would be downtime. People would be querying your system on premises Arc for a few hours. So that's different with the cloud move. In the past, we basically are able to do that independently without any issues. But then, this we all know. Where do we go to now? And that's basically in Polaris, we're decoupling state and compute as well. And we're also want to decouple those transactions, because stateful means we're still going to have those transactions in our compute node, which basically means if our compute node fails or if we're scaling anything or have anything to do with that compute node, that query can still potentially fail or cannot be restarted. Now, Polaris is built that it's a stateless, so data, transaction log, metadata, everything is externalized, which means we can have flexible scaling during our query execution. These resources scale up, scale down, or scale out, whatever you want to do with it. And this also gives us a partial query execution restart in the case we have a compute failure. So for example, if we have our query running here, let me show you over here. Oh, wrong screen. Let me show you here that we have these 3 nodes which are running a query, a distributed query processing, a little bit more on that later. Let's say this node fails here. So this node fails. What happens is this part of the query just gets restarted on the new node without any impact. So that's the restartability of those queries. Well, previously, if our compute node would go, for example, a dedicated SQL scale operation, that query would stop and wait until you you've done your compute scale operation, and it would have killed your query. While in this case, a scale operation will not kill your query because it basically just takes up a new node. So that's the Polaris engine that's behind that. Now, how does that work from A to Z? It's a very simple explanation. There's a lot more in the white paper. If you want more information, I'll link to the white paper later. But basically, this is a very simple explanation on how it works. So first of all, query request comes in. We're going to look at our storage layer and find out what data cells we need to do this query. So we can see over here that we have these 4 data cells that we need. Those data cells are then mapped to tasks, and those are the query tasks. So the externalized tasks, while previously they would be in a transaction in compute, these are now externalized tasks. And that moves on to mapping those cells to the tasks, to query tasks, which then get executed. And let's say we're executing these tasks that you see over here. These little triangles are all single tasks, and they get distributed over these different nodes. And they start executing. Okay. Now, let's say one of those nodes fails, like I showed you before. The second node just takes those tasks and fills those up. If you have, for example, a longer task running, so you've got a task that needs to be redistributed, it just takes the task and redistributes it over other nodes. You can scale out very easily, but the cool thing is this is all SQL Server in the background. So the core thing that's underneath there is SQL Server, which allows us to use the whole query optimizations things that we've been developing for so many years with SQL Server and dedicated SQL pools. It's basically in there. So any query plan optimization statistics, everything is in there. And the cool thing is we not only scale out these nodes, we can also scale up. For example, this task was taking a bit more time. We can say, okay, we need more memory to actually go and do this query. We can also scale up these specific nodes to make sure that those tasks can run that specific query. And that's, in a nutshell, the Polaris engine. So how it works. It's a distributed query processing with multiple nodes, which you can scale up and scale out in an easy way with data cell abstraction, and then moving those data cells into query tasks. And those query tasks are restartable, which means that we can scale up without any interference to our actual system. And that's basically what's behind that serverless SQL engine. More information can be found at this link. I'll also share the presentation later so you know where to go and where to find this. Okay. Now, let's go and move forward with serverless SQL Pools. So serverless SQL Pools is a stateless on-demand query engine. So stateless on-demand query engine, like I just explained in the Polaris white paper, but it's on-demand. And on-demand means whenever you want to execute a query, you have no cluster startup time. You just query those files directly, which means if you want to query your Parquet files, which are in Data Lake, you just right-click it, just say select top 100. I'll show you later. It will instantly give you the results. You can join those tables. You can build views. Because it's SQL Server on the lower end, you can have the whole SQL Server suite, which is behind. You can have security settings. You can have views, tables, data sources you can have all these things you have in SQL Server are in that on-demand SQL pool as well, that serverless SQL pool. So you can create external tables or views on raw files. You can query Apache Spark tables directly. So if you've created those Apache Spark tables in your Spark database, you can just reference across database queries. So everything we've used to do, like cross database queries, that didn't work with the Spark databases, that works. And it is cool because it's C-SQL code. I have never been involved with a lot of .NET code or C# code. So SQL is kind of my core. And this made this technology a lot more accessible for a lot of our developers and for a lot of people who are used to working with T-SQL and do want to work with that more file-structured, file-based data, which is a bit more unstructured. So it's pretty cool. And that's serverless SQL Pools in a nutshell. But let's see what that actually does. So let's start off with our first demo over here. So let me go over here. You can see that I have a storage account here, which basically is Synapse in a day, it's called here. And I've got a folder with CSV files, which has taxi data from the taxi data set. I can open this one, just right click one of those taxi files and then select top 100, run this. And you can see that automatically it just starts giving me results in a few seconds. So basically I'm reading that file right now, selecting a top 100. And you can see over here, it just gives me back the data. I didn't specify any column names in here, so it's just giving me C1, C2, C3, C4. You could specify that. And also something to note here, we've got parser version 2, which is basically optimized to read that data a bit faster. There are some limitations to it. For example, your maximum row size is 8 megabytes. The maximum character column length is 8,000. But it basically works better when working with larger files. Okay, so let me switch over because now I'm working in that Synapse Studio. But what you can also do is you can just connect using your SSMS. If you're used to working with SSMS like I am, you can just say connect to the database engine, connect to this specific server, which is an endpoint, and we're able to see the databases that I created here. So this is my Spark database. This is a database I created, a logical database, and this is also a serverless database that we have in here. So we just queried that CSV directly. Apart from having that one file here, we can also query all the files in one go of those CSV files. So we can just do a count of all these files over here. Okay, I need to make sure that I'm on the right one here. Give me 1 second. It's Synapse in a day, Synapse in a day, Synapse in a day. There we go. It's this one. There we go. And then let's change the connection. Let's just do a new query here. New query. Bear with me for 1 second. Of course, it's the thing when you have multiple things here. There we go. So I can query this folder directly, as you can see over here. I'm now just getting a count of that folder, which are CSV files, and it's just going to list me the amount of CSV files that I have in here and the amount of rows that are in that CSV file. As you can see over here, I'm working with 843 million rows. So in about 11 seconds, in about 11 seconds, I was able to query all those files together. I can also, if we go back over here, we see raw NP. If I go over here on the raw and then taxi NP, you can see that we also have Parquet files here. Same thing, I can do select top 100 here or go to my SSMS where it's prepared and just query that Parquet file. And if you can see over here, there we go, 100 rows are selected. You can see that it went a bit faster because it already created statistics on this one. And then you can query the full folder as well by not specifying the file here. So I removed the file here. I can query that full folder. So if I do a count one of that full Parquet folder, you can see that we're here with our 1.4 billion row data set. So quite a beefy data set. And then we're just able to query 1.4 billion rows in less than a second. So quite impressive if you ask me to do that based on files. OpenRowset has inverse schema. So basically, if you select account or select star, it will give you a schema. But you can also basically tell it what it needs to be, and you can do that with the width over here. So you can just say, hey, these data types for this table are like this. Why is this better? It's SQL Server in the background, which means if we specify our data types, it has better memory grants and it can query your data a bit faster. So data types are always still important. Okay. As you can see here, you can just query it like that then. And over here, I've got this WWI Spark, which is a Spark database, which you can see over here. If I go to my workspace, WWI Spark, these got these Spark tables in there. It's a Spark database, as you can see over here. I can just say, hey, cross database reference this and give me a select top 100, and it also works. Okay. You can also create external tables, same setup as you would have with dedicated SQL Pools. So you need a file format and external data source. So let's create those two. And then I'm going to drop it because I think I already created it. Nope. And then just create the table, external table. And as you see here, it points to that data source, to the location, the folder it needs to be in. And then we can go and select some data from it. There you go. Basically, it's built upon that folder that we have here, which has all those Parquet files in there. Okay. Now, moving forward, we can also create a view on this. So basically, you can use OpenRowset on that selected. So if we do a select top 100 here, like we did over here, you get this OpenRowset bulk and then your format. You can also have that one for CSV. We can also do that with, we can create a view out of that one. So I can specify my schema and everything like that. Execute this. And then you're able to just, without writing that OpenRowset, we can just do a select top 100 of that taxi view that we just created. Okay, so everything is basically kind of native in there and it works quite fast. So that was step one, very, very easy. So we just started building some stuff and you can see that we're querying these files directly. I'm not using any databases, any disks that are attached to that serverless. It's basically on demand, give me these queries, execute these queries, and they perform in quite a fast way because we're working on a 1.4 billion data set, don't forget. Okay, let me switch back over to my presentation. Now, that was quite easy. So you can use these things because we've got the SQL Server table, external tables and views and all that security and all those things in the background. We could potentially create sort of a logical data warehouse on this. which you can achieve with building views and tables based on those raw files. And now the thing kicks in is you're going to pay per terabyte of data consumed. I don't know a lot about pricing, but I always get the question when I'm presenting this session. So it's about 4 or 5 euros per terabyte, and it depends on the first X amount of terabyte you don't need to pay. I don't know how it works, the payment, but it's about 4 or 5 euros per terabyte. Let's leave it at that. Okay. And so it's important that you try to reduce the amount of data that you read. So if you're always going to read 1 terabyte of those files to get sort of a calculation or something like that, this solution will become more expensive. So what we want to do is reduce the amount of data read to actually cost optimize it. But not only by that, we're not only cost optimizing it, we're also making it faster. So let me show you what the difference is between CSV and Parquet. So let me hop over to demo 2. And I'm going to do a count from that taxi folder that I have over here. So if I go over here, I have this one up here, linked, Synapse in a day, the CSV folder. So I'm getting all these CSV files over here and doing a count on it. And then I'm also going to do that on the raw taxi MP folder. So if we go to raw here, you see taxi MP on this full folder. Okay, so what I'm going to do is I'm going to do a count 1 on the taxi, execute, and that cannot be listed because I am again in the wrong one here. So let me just do a new query over here, paste, let me get this one over here as well. Bear with me for 1 second. There we go. So I'm going to do a count 1 on this one, which is the CSV part. And then I'm going to do a select count 1 on the Synapse, on that Parquet, on those Parquet files. Okay. There we go. This has executed. Now, if we want to go and see the amount of data consumed, you can also see that over here, by the way. It will give you the amount of data scanned and looked at. But you can also go over to your monitor tab that you have here, and then to your SQL requests. And then over here, you can see the difference in the amount of data that has been read. So we see over here that we have that this is the CSV one, this is the Parquet one, and the difference in data read. So the CSV one is going to read 11.17 gigabytes. The Parquet one for that count is only going to read 10 megabytes. It's because Parquet basically is also columnar storage, and it has metadata embedded in it. And it also has row groups and segments and all those things. So basically, we're able to just read that metadata, get that count back. So it really, really reduces the amount of data that we're reading there. While CSV, we always have to read in the full CSV. It is still quite fast, but we always have to read in the full CSV. So if you have to choose building it in a cost-effective and performant way, you should look at the Parquet option and not the CSV option, because that will always need to read the full files. Okay, so for the rest of this session, we'll leave CSV on the left-hand side and we'll work with Parquet only from now on. Okay. Okay. So Excel and JSON will read all the files when we want to get the count. Parquet only reads the file metadata, and if we would do calculation, Parquet will also be able to eliminate that set of data a little bit. So moving on, what we're going to work with today is the taxi dataset. So the New York taxi dataset, you can get it for free at TLC Trip Data, it's called. You can also, at Microsoft, we have some samples in the Synapse Studio. It basically gives you also an X amount of rows. I basically did the hard job of getting all these CSVs in my storage account, revamping them to actually have the full 1.4 billion row data set, which has that data in there exactly as it is in the CSVs, and it's not a small subset. It's 10 years of worth of taxi data, so it's a big data set. So what I'm going to do now is I'm going to start building a report. So we're going to switch over to Power BI, and I'm going to show you just that you can connect out of the box with that serverless SQL pool, because it's also you're able to connect with your SSMS. It's a SQL server, so you can just say create SQL Server connection, and you're able to connect to that Power BI. We're going to use direct query because I don't want to load in 1.4 billion rows into my Power BI desktop, because then I will break my my machine here, and then we won't have any session here today. And I'm going to show you how to report on this giant data set just using those files. Okay. So let me switch over to the first one over here. As you can see here, I have an external table here. I'll just show you how you can get that data. So if you just say get data SQL Server, and then you need to give in your server name. You can always find your server name if you haven't used Synapse before. Over here, the serverless SQL endpoint. You just copy this, you head over here, paste it in, an optional database name. Let's say we're going to give in our database name. Which one are we going to give in? There should be one that has our taxi DW, which has an external table with taxi. Yep, so taxi DW, that's the one we're going to give in. Taxi DW. Okay, and it will create a connection. And then it will find your external tables, as you can see over here, and my views. Okay, and then you can just click taxi, load, and it starts loading that table. I'm not loading the table, only the metadata, because we have direct query enabled. Okay, I'm just going to cancel this. And once we've got this taxi data set in here, we can go and start playing around with this a little bit. So I've created a slicer on vendor ID. I've got a calculation total amount by passenger count, and I've got 1.4 billion rows in this data set. So what I'm going to show you is I'm just going to go to view. I'm going to take the performance analyzer, start recording, and refresh these visuals. So what I'm doing now is I'm just querying those files. So I've created those external tables, and these external tables are now going to give me the calculations that I just did here in this report straight onto those files. No optimizations yet. But just to show you, it's really easy. It's just an external table. It looks like a table, so Power BI can just work as it should work. And you see the slicer took about 6 seconds. The total amount by passenger count is also taking 28 seconds now. And then this card to get this count will take also some seconds. If we look at what's happening in the background, we can go and see over here in our monitor tab, SQL requests. We can see that that count that we had here came in from that table. This is the Power BI query, which is doing a count big of the TPO drop-off date. We see that we have a 5-second query here, which was going to get the maximum vendor ID and the minimal vendor ID. So basically the queries that gets generated from these. And you can see also the amount of data that we're reading here. Okay. So quick and easy to build a report on that serverless, build upon files. We kind of created a few tables and we're able to query that now. Okay. Let me switch back over to my slides and let's move on. So this was pretty fast. So 20 seconds on 1.4 billion rows. For me, this is quite fast. I can't say a lot of systems on SQL Server base can do that in just on files in this way. But can it go faster? Yes, it can go faster. One of the tools you can use is partitioning. And partitioning, you say you can partition your data set, for example, for a certain way that you want to query that data. So you can partition your data set, for example, by year. And that's also what I did. So I have this taxi data set and I partitioned that data by year. How do you do that partition? You can do that using data flows. You can do that using a notebook with a Spark cluster. Basically, there are multiple ways to roam, and this is one of the ways you can do a few of the ways you can do it. But basically, I created that partition data set by year. And the cool thing is, remember that if we do a select top 100 of one file, we have that open row set, which has the full file path. What you can do is you can just say, give me a few wildcards in this file path, and that file path has a file path function, which you can then reference. Let me show you how that works. So let me head over to demo 4 over here, and I am going to make sure I am in the right server here. So that's this one. There we go. And I'm going to first query a non-partition table. So I'm doing a select count of that non-partition table. There we go. Execute. And this is getting that 1.4 billion row data set. Okay. Then I also created a partition table, taxi. So if I switch over to my storage, sorry for all the switching over, but it's just to show you all the things that we can see here. So if we go to linked to that raw, the taxi folder that we have here, you can see that's partitioned by year, and then each year has X amount of Parquet files, depending on the cluster size you built this with, by the way. Okay, so let's switch back over to this partitioned file and let's do a count of that folder. So you can see /star. So I'm just going to select everything inside those subfolders. It's recursive. You can see also 1.4 billion rows. Now, let's say I am going to get from that non-partitioned the data, the total amount of sales by vendor ID by the year of the pickup date. So I'm going to use that partitioned one that I have. I'm going to build that here, that query using the non-partitioned view. I'm going to start executing that. And it's basically going to execute this query and see what we need to do to leverage that. So we're basically going to read in all the data at this moment because it's non-partitioned. We don't know where which year is. And then it's going to create that year and then filter on those years. So we're going to read more data than we should read if we partition our data. As you can see, still doing that, still doing that on that big data set, it only took 21 seconds. And if we look at the amount of data read, you can see that we read about 3.6 gigabytes to execute this query. Now, let's say we're going to get the same thing with that partition data set, and you can see over here that I have this star. And this star we can reference with this specific function, filepath. So filepath1 references this star over here. So I can say result.filepath as year, and that basically tells me that that year I created, that column, I can now use, and that's basically just a folder. And what happens if we query that one? There we go. Execute. This is just going to get the data from those two files. So we can see now we're querying in 3 seconds. Previously, we were talking about 16, 17, even 20 seconds to query that data. Same query now happens in 3 to 4 seconds. And looking at our messages, we can see that the amount of data scanned went from 3 gigabytes to 570 megabytes. So we also reduce the amount of data we're processing, reducing the cost, increasing performance. So yay, all good. Okay. You can then, for example, create a view out of it, and then create that partition table into a view with that file path in there. And so that file path gets endured in the view, and that view then basically is something you can use in your reporting. Okay, something we will do later. Okay, so let me switch back over to my presentation. So that was good. So partitioning can reduce, considerably reduce the execution time of those queries. Can reduce it even further. Now, the second enhancement you can do to your Parquet files is data elimination, I like to call it. And this is basically looking at the row groups that you have inside of your Parquet files, and basically you can also skip certain row groups by ordering the data inside those Parquet files. You can order that data using Spark. I'll show you quickly on the notebook how to do that. But basically, ordering your Parquet files can reduce the amount of the amount of files you're going to need to read. And reducing that number of files that you're reading will reduce the amount of data that you're reading. But the cool thing is, you don't only reduce the amount of files you're going to read, you can also reduce the amount of parts of that file you're going to read. And that brings in a new concept with that ordering. So if you order that data correctly, you're actually reading less data. So let me show you that. So let's go to demo 5. Where's demo 5? There we go. And then see if I'm on the right one. This is the wrong one, so change connection again. There we go. And let's go all the way up. So what I'm going to do is I'm going to get the distinct PU location ID. So PU location ID over here, distinct one of the taxi non-partitions. Okay, as you can see here. This will execute, and this will execute in about 15 to 20 seconds, and will give us back that we have 266 distinct PU location IDs. What is also cool here, we've got this function called file name. And file name means that we're going to see for each file that we have in our data set, how many PU location IDs do we have inside those files. Okay, so for that non-partitioned one, if I execute that here, you will see that we have about 266 for each file. Sometimes we have 40, depending on how big the pickup location IDs are. that are referenced, but you can see over here that we have about equal distribution on those Parquet files on the pickup location IDs, as you can see here. Now, what I did is I ordered this pickup location ID. I will show you later how I ordered it, but I ordered these Parquet files on pickup location ID. So what I can do now is I'm going to go and get a distinct by that file name. So I'm just going to get the amount of data that I'm getting here is from the PO location ID by file name, and you can see that there's one PO location ID in this file, another one in this file, two in this file, one in this file, and so on. So basically, we know that certain Parquet files only have one or two PO location IDs. Now, how did I create this? Let's go over to my notebook here. So that's develop tab here, and then notebooks, and then sorted Parquet. Let's see. Okay. So what I did is I basically loaded that NP data set, and then I started loading that NP data set in there, put a table in it, selected some data, basically some data exploration in my Spark. I need to get my head around it, so that's what I always do. And then I did something over here. Where is it? Did I? There is an order. Wait, can order them. I need to go to the other workspace. 1 second. It's over here. Notebooks, data loading. Is it over here? I kind of. Okay. No worries. Let me just show you what I did. So what I did was with one of these data frames, there is a possibility to df.orderBy. And I ordered by that PU location ID. So I can do order by and then just say PU location ID, and then it's going to order that data of that Parquet in those PU location IDs. And that's what you can see over here. If we go to our data branch, to our Synapse in a day, the raw one, this one over here, sorry, this one. What folder was it in? Sorry, it's SQL Stand Training. So that's of course in the different one now. It's SQL Stand Training PU location ID. So SQL Stand Synapse over here, data linked SQL Stand Synapse over here, and then if we move over to our right folder, so SQL Stand Trading DFS Core. Okay, this is the wrong workspace again. Anyway, let me quickly show you. I've got my Storage Explorer open here as well. SQL Stand Trading, and then over here, if this opens up. Anyway, it's also in a folder and it's structured and it's just Parquet files. I'm not going to focus too much on this right now. But the cool thing is I then ordered this and that's how you created this. And I'm now going to create a view on that ordered data set. Okay, that's already there. Okay, no issue. And then I'm going to create a view for that non-ordered. Is that in here as well? Okay, that's also in here, but good. And now I'm going to select from the ordered and the non-ordered. So where the PU location ID is in 2 and 3. Okay, this is going to execute in the background, but switching back over to my notebook here. This one, sorted Parquet. What you can do is you could load one of those files to PyArrow. And what I did is I took that file that had location ID 2 and 3 in there, and I loaded that to a PyArrow dataset. I'll give you the code after this session. Basically, what you can do is with that PyArrow, you can go and get the metadata. And the metadata then shows you, I've been running this notebook for some reason. What this does, it shows you that in this row group, you only have the max value of, so the first row group inside that file has value 2, and the second row group has value 2 and 3. So if you then query that data and just say, give me the PU location ID 2 and 3 over here. Let me execute this. You can see that the messages, this is in the same file, that one will read 27 megabytes, which has in both segments, and one will read 22 megabytes. So we actually have data elimination on file level as well. Okay, so that's an extra optimization you can do. And also the amount of data read here between these two is also a big difference. So the first one is going to be a lot slower than the second one because we're able to only read one file while the other one needs to read all the files. Okay, let me switch back over here. And now what you can do actually is, using all these technologies, you can start building your logical data warehouse. So you can create a database. Very important, make sure that you use a UTF-8 correlation because it might, with Parquet files, it can give you a conflict with the searchability of your queries for the DQP. So make sure that you put it in UTF-8 correlation so you don't have any correlation conflicts there, which will make more scans of data inputs instead of an actual seek of the data, sort of seek, okay? Create external tables and views for those folders, and then create a Power BI model to do that. And very briefly, I have those Power BI models created. So I've got this data warehouse over here, which I've created. And this basically has the tables in their taxi NP and the pickup drop-up location linked to it. And what I did here is I got the total amount here with the pickup date and the PO location ID and a very simple report. I'm not a reporting guy, but I just tune the queries that are coming from that report. And as you can see over here, this took about unaltered, takes about 15 to 20 seconds to do all these queries. Then what I did too is I built up the logical data warehouse with the alterations that we just did. So I added partitioning and I added ordering. Let me switch over to that one. Same report that now executes in about 5 seconds in total. So we went from 20 seconds to 5 seconds in total, and we greatly reduced the amount of data read. So we've got now a performant, cost-effective way of reading data with serverless SQL pools on 1.4 billion rows using serverless SQL pools. So for me, this is quite impressive and very fast. But remember, if you're going to try and build this on your own solution, make sure that you do those things with your Parquet data set, that you repartition them, that you order them, and make sure that you don't overcomplex it. Because some notes to close down with is more metadata will give you slower queries. So if you have a lot of small files, it will need to create statistics on all those files. Having that more metadata can reduce the query speed that you're doing. I saw something with store procedures to prevent parameter issues, but I'm not going to focus on that right now. There's also aggregated tables that you can use. There's a good post by Nicola Illich about this one, on how to optimize with those aggregated tables as well. And also very important, if you're using SQL authentication and all those things, security needs to be linked to those code credentials. Now, to summarize, we talked a bit about the Polaris engine. So basically that's scale out, scale up, it's SQL Server underneath, and it takes your data cells, puts that into tasks, and the tasks get distributed across all nodes. Then if you're looking at CSV and Parquet, CSV is not the most effective way of doing it because CSV will always read the whole file. Well, Parquet can reduce the amount of data that you're reading by just focusing on the metadata that we have in that Parquet file and just reading the column that we need and also the segment of the data that we need. You can use partitioning and file paths to basically reduce the amount of data that you're reading as well. And you can have data elimination inside your Parquet files with ordering. So what did we learn? Understand the Polaris engine, read and optimize reading data from a data lake in a Parquet format, and build a report based upon those files in a performant way. And on that, I have 2 more minutes for questions.